And welcome everybody to the Daily Space Weather. Today we're talking about solar flare and coronal mass ejection watches, which are in effect. I've just issued them. Also, some transients, Sagittarius A stars quiescence, and of course, images of the sun. I'm your host, Dan, aka smAsho. Let's get started looking at the sun here. Here's the Dopplergram. We don't always show this, and like a Doppler radar, this is showing you changes in the sun's surface, and you can see sunspot 2795 and 2794, which is the trailing group there. Two significant umbrae associated with that, as well as some subgroups. We'll show you in-depth analysis. The radio flux, a measurement of the radio output of the solar outer corona at 88. There's the 1-year graph of the radio flux. And there's a graph of sunspot number progression. Welcome to cycle 25. There's the radio flux progression. And we'll talk more about solar cycles during the cosmology section. Here's the 1700 angstroms view. Another one of the very hot UV emission spectral portions of the electromagnetic spectrum. Great images from the SDO there of sunspot 2794 and sunspot 2795. And by the way, we are streaming live to Twitch. Thanks to all the new viewers over there on Twitch. Thanks everybody who's been viewing the content on Twitch. It is a great streaming platform. And let's get back to more stuff. We've got some fantastic Helio viewer movies for you today. And before we go there, let's head out to Lagrange point 5. At Lagrange point 5, we have a spacecraft called Stereo A, and it gives us probably the best view of coronal mass ejections that are Earth-facing. So we can see these large plasma plumes out here. Epic pen is failing. Under my pointer here, you can see these large plasma plumes right here. And since we've got Earth-facing sunspots, there is some chance of coronal mass ejections to occur in the next day or two. And some significant solar flares also here on the opposite side of the Earth. So the Earth would be out in this direction. And here on the opposite side of the Earth, you can see Venus, but also a large plume of plasma out there. Don't be surprised to see that eject as well. And here's our first Helio viewer movie of the day. I don't know what happened to the Earth scale there. It's all koofed. For some reason, it's split. But anyway, there's a full disc 1-day video of the sun in 171 angstroms. Coronal whole system there, right in the Earth-facing zone right now. To the northwest of sunspot 2794, which is quite Earth-facing now as well. And here's a magnetogram, and we'll show you some close-ups of that at the end of the video. First, we're going to go through a whole bunch of data and talk cosmology for a brief moment. Before I do that, I would invite all of our viewers to check out smAsho.com. You can find our social media accounts there, as well as our stores and our forum. Thanks everybody who's signed up at the forum. smAsho.com/forum. If you want to read about our mission, you can read about that at smAsho.com/forum/mission. We won't talk about it today. Thanks to our new subscribers over on YouTube. Thanks everybody who shares the content on your social media. Shout out to all of our loyal and disloyal viewers. We're also on BitChute, thanks to our new subscribers over there as we approach 300 subscribers on BitChute. And let's get back to some data. Here's where things are located in the solar system. We hope you had a delightful Christmas. Here's where they are on the day after Christmas. And there's where things should be in a week. Next, looking at a star chart here, if you're up before dawn, you may see Venus rising before the sun, the third brightest object in the sky, my favorite planet. And please leave us a comment if you remember when I used my crystal ball to forecast that Venus and Mars would switch places. Again, we are streaming live to Twitch. Cheers once again to our viewers over here at Twitch, twitch.tv/smAsho. They've also got a great mobile app. It's a fantastic streaming platform. If it's good enough for gamers, and I am a gamer, by the way, it's good enough for me. Today's cosmology segment's going to be brief. Before we get into that, let's thank our patrons. Thanks, patrons, for being spaced out enough to support us. Our patrons are the main source of funding for the content. Please consider becoming a patron. The site is patreon.com/smAsho. And thanks to our newest patron. Today we're not going to roll any dice, although we do regularly roll dice, between 1 and 1031. Why? Because there are 1,031 entries at the Neil Gorell's Swift Bat X-ray Observatory. Today we're going to look at the X-ray transient outbursts of the core of the Milky Way galaxy, known as Sagittarius A star, the massive radio source located at the core of the Milky Way. So in the upper right, you can see the historic chart there. That's about 16 years worth of data from Sagittarius A star's X-ray outputs. And according to the bottom left, it's gone into a quiescent state here over the past 20 days, which is kind of perplexing because the 3-day chart in the upper left shows transients. So I don't know what's going on with that. Perhaps some sort of a failure to update. Let's look at probably the most important transient source, at least in terms of directly to the Earth, in terms of geophysics. It's a known cosmic ray point source known as Cygnus X3. I won't get in depth into that, but if you want to read all about Cygnus X3, head to smashomash.com/forum, and in the cosmology segment, you will find this oddity. It's got a 4.8-hour periodicity that goes on and on and on, but it also varies in X-ray state. It's a high-mass X-ray binary consisting of a Wolf-Rayet star orbited by something resembling a more massive radio source, referred to as perhaps a neutron or a quasar or a blazar or a quark star, or all kinds of theories as to how Cygnus X3 does what it does. And it's ramped up a little bit here in the past week, moved into its X-ray loud state. And we're trying to encourage radio astronomers to get a fix on Cygnus X3, as we've got, Cygnus X3 has now moved into its loud X-ray state. So you can see most recently here, we see these loud transient bursts. That dotted line there in the lower left, that is the baseline X-ray output for Cygnus X3. You can see it in the sky also. Cygnus X3 is also associated with the brightest intrinsically visible object. So the brightest intrinsic object visible from the Milky Way galaxy is a star called Deneb, which is also the celestial pole star, and we won't get super in-depth into it. It's also a known cosmic ray source, so let's take a look at cosmic rays. First, we'll look at the Apatit and Barentsburg neutron monitor stations. There is Apatit, and you can see indeed an uptick here in the past week at Apatit. Barentsburg, similar uptick there, not quite as extreme as at Apatit. Bear with me a moment. I want to take a look at the life of the stream here before I continue on. Thanks for leaving us comments. Precious Slights and Kathy Garden, good morning to each of you. And cheers. Yes, the year did go by quickly. The next cosmic ray station we'll look at is much farther south from Apatit and Barentsburg. It's the Athens, Greece cosmic ray monitor. There are the neutron detections at Athens. Slight uptick there over the past week at Athens as well. Next, we'll go even farther south to Mexico City. And there you can see a slight uptick there over the past week, although a downtick over the past 30 days at Mexico City, as the sun enters a more active state. Lastly, we'll look at Oulu, Finland, and DOMC, Antarctica. There's Oulu, an uptick over the past week at Oulu as well, which makes it actually flat over the past 30 days. And there's DOMC, Antarctica, downtick over the past 30 days, no uptick over the past week. And DOMC, Antarctica, not really sending data. And we do monitor those daily. And that's today's cosmology segment. Keep in mind, folks, all your weather comes from space. And cosmic rays are very important as they can cause sudden cloud nucleation, and indeed they seem to be associated with periods of cloudiness on the Earth lasting for perhaps thousands of years. And so we monitor cosmic ray flux on the channel. Next, we'll look at some more current data here. It's the real-time solar wind, I think, something we regularly cover at the Smash News Network, which, by the way, is the least busted name in news. Why do I say that? Because we're not busted at all. We don't really talk any nonsense or fear-mongering on the channel. We did recently see a sudden downtick and then an uptick here in the solar wind density. Check it out. Solar wind density went from 4 protons per cubic centimeter all the way down to 0.39 protons per cubic centimeter. So a magnitudinal loss of protons there happened between that time period, between 6 o'clock universal time and 9 o'clock universal time, a 3-hour ultra-quiescent state there in terms of solar wind density. Current conditions back to about 5 protons per cubic centimeter. Solar wind speed currently 429 kilometers a second. And we see an ongoing phi angle near the middle of the range here. And also the BT/BZ are fairly convergent on the 0 line, indicating that the north and south polar fields are currently fairly consistent with each other, at least as measured at Earth. KP index is at 0. That's part of the reason why we showed you cosmic ray flux. And next, looking at the pressure in the magnetosphere. This is the Geospace Magnetosphere movie pressure version. And there are 2 other panes above here if you want to monitor this yourself. It'll show you 4 hours of data on most days. And we see a very steady solar wind. We were a little bit too late to see that extreme downtick. Next, we'll show you geomagnetic perturbations on the ground level. It's 4 hours of data, and we don't see many changes in the Earth's B field here at all. And there is not a lot of induced magnetism from incoming solar protons. Not a lot going on there in terms of the Earth's B field. Changes in the Earth's B field is what geospace delta B means. Next, looking at the proton flux here, and it's flat over the past 3 days, and indeed the past 7 days. No proton events, and we cover them quite promptly when they happen. Here's a 3-day chart of the GOES X-ray flux, and really seeing a very quiescent state of solar flaring as well. And don't get your protons and photons mixed up, folks. Protons are what happen during a coronal mass ejection, and photons are what we're measuring with a solar flare. A regular subject in our comments section. Here's a 3-day chart of the GOES magnetometer. It's a little spiky here, but nothing to write home about there either. And next we're going to look at the polarity of the current sheet as well as some data about the solar polar fields. And shout out to Eugene Bagashov for engaging me personally in interesting conversations about plausible explanations for the solar cycle. So anyway, here's the last image. And the Earth is, as you can see here, solidly in the South Pole-oriented portion of the current sheet, shown in red, North Pole current sheet shown in green. Now, next I'd like to talk about, for a brief moment, the solar polar fields, which are directly associated with the solar cycles. So let me shrink this down a little bit. This is from the Wilcox Observatory. And if you head to solon.info/solar, you'll be able to find a link to this. And we wish this would get updated, as this is nearly 6 months old now, having the last update happen in July. So as you can see here, North solar polar field pretty weak compared to the last cycle. South solar polar field stronger than last cycle. And part of the forecasts of a grand solar minimum are associated with this data right here. The idea that the solar polar fields will cancel each other out through an interference wave. Here are the unfiltered data on that. And this is really the same data here. It's just that this is filtered. It has to do with the position of the sun versus the Earth during seasons and so on. And again, you can find all those links at solon.info/solar. That's the radio flux chart that we show daily on the videos. Next, looking at the line of sight coronal field plot, coronal hole field plot rather. You can see an Earth-facing coronal hole there, just moving out of Earth-facing longitudes. It's South Pole based, and there's a mixed coronal hole up there in the north as well. You can see some red and some green up there north of the equator, just rising in the east. And here's a line of sight field plot which also shows you the magnetogram. And the sun's B field here is shown in blue. Next we'll talk electrons after we look at the coronal magnetic field plot. There's the magnetic field plot of the corona. It's pretty trippy, man. It's pretty trippy. Next we're going electrons. And what we're looking at here is a diagram of charging hazards for satellites, and we don't see many despite being at high levels of electron flux. So that's kind of surprising. There's the one-year chart of the relativistic electrons. And here's me taking a break to check on the life of the stream. Kathy Garden asks if the solar polar fields cancel each other. Yes, they can cancel each other depending on their strength at certain periods of time. But they can also magnify each other. It's basic wave dynamics. And I can't get too in depth into that as this is daily space weather, and we don't want the video to be too long. Next, looking at the relativistic electron forecast, and NOAA forecasting flat for tomorrow and an uptick on Monday. So not exactly sure the reasoning behind that one. I won't refute it as I haven't even considered it, but we're just about to move into electron flux warning levels here, which happen at 1,000 pulse flux units. You're looking at electron density on this graph that's measured by the GOES 16. Here's a visualization of the air column. And it looks a little inconsistent with the electron flux graphs. I'm a little perplexed by that, and hence I won't conjecture and say something stupid. Something that Jordan Peterson and I share. We prefer to not say things that are stupid and to only talk about stuff that we seem to know something about. Anyway, that's a visualization of the air column. And we're talking the whole air column from a GPS satellite all the way down to your handset. That's why we show this diagram afterwards. This is all measured in miles. And here's a different view here measured in kilometers. And that red F over there on the right side, right over there somewhere, that's where the GOES 16 endeavors to make its measurements. Here's a visualization of just one slice. It's that F layer of the ionosphere. And we see some big anomalies here in the southern hemisphere. Some major charge-ups there, and some major low-frequency rifts in between the noontime portion and Antarctica. So big anomalies there in the southern hemisphere of the ionosphere. Also south of the South Atlantic anomaly, which is somewhere around here. So an indication that there indeed is a second South African anomaly that's kicked up. The two weakest points in the Earth's magnetosphere are right about here and right about here. So yeah, some anomalies covered there. Next, let's look at volcanoes, see what's been erupting. Kluchevskoy on the Kamchatka Peninsula indeed is producing a 22,000-foot ash plume, 8,000-foot ash plume over Sakurajima. Suwanosejima, 6,000-foot ash plume as it explodes. Popocatépetl likewise exploding, 20,000-foot ash plume there. Fuego, 16,000-foot ash plume. Sage, 22,000-foot ash plume. And while we don't see volcanic ash in Revenador's webcam, and while we're unable to detect the emissions of Sabatkaya, please do not attempt to pole vault either caldera. it could make for an unhealthful day. And we've got a pretty anomalous low pressure system here over the Aleutian Island chain. And if you look at the differences in the isobars here over this low pressure system, you can see it's much more concentrated toward the east. I'm sorry, toward the west. You can see how close those isobars are on that side and how far they are on the other side. It's a bit of a rapidly changing low pressure system, most likely. Let's see if it does indeed rapidly change as I advance the GFS forecast. Not so much, but it's making quite a turn to the north there. There's where the GFS forecast believes pressure systems to be at noon tomorrow. And we cover that daily because there's all kinds of different variables that we need to look at when looking at the Earth as a whole. Unlike proctologists, which look at your butt as a whole. Too many electrons. I don't know. No, not really too many electrons. It's not bringing me down. All right, so next, looking at earthquakes over the past 24, we don't see any major any quirks or quakes as the earthquake drought continues, folks. We're seeing a massive drought of 6, 7, 8, and 9 magnitude earthquakes. And Kilauea is still erupting, it certainly looks like. Let's just see what we've got. We reported a ton of deep earthquakes yesterday on Christmas, such as this 4.0 at New Zealand at nearly 200 kilometers. There's another deep one at the Philippines. That one coming in at 8:25 today. So deep quakes kicking up once again today. Here's 2 in succession. They're about an hour and 15 minutes apart and close together, geographically speaking, at Argentina and Argentina, at a similar depth and magnitude, 232 and 246 kilometers and the mid-4 range. Here's an extremely shallow quake in California, 1,800 meters above sea level, just to the northwest of Lake Tahoe. Check it out. There's a location of that. And it's only a 2.9 magnitude, but it's at a depth of negative 1.8 kilometers. Another deep quake in the Solomon Islands at a 5.1 magnitude. And we'll smoothly scroll up the rest of the list here. I will also zoom in on Hawaii real quick. Or I'll try to. And so there you can see a quake under Mauna Loa, as well as under the southwestern flank of Kilauea, just south of Pahala. Let's move on to look at jet streams. And we see some extreme jet stream bends in the western hemisphere. Here's the eastern portion of the planet. And we do see some extreme kinks there as well in the southern portion. And check out the western portion of the world. The Atlantic Ocean has backward jet streams happening over the North Atlantic. This will affect things like transatlantic flight paths. And you can see the jet stream blowing here, significant portions of it here blowing east to west, which is indeed backwards. Also a doubled up jet stream at extreme bends over the North Atlantic. Doubled up jet stream there over the North American continent. And some extreme bends over North Africa as well, pulling cold air into North Africa and blowing warm air into Eastern Europe. If you're wondering where lightning's striking, which I do when I hear thunder, I use lightningmaps.org, and I freak out my foes and impress my friends by forecasting thunder. You can do it too. At lightningmaps.org. Here's a visualization here, the GOES 16 lightning mapper. And that long band of lightning there in the Atlantic breaking down a little bit. It was extreme yesterday. Here's a U.S. Doppler radar map as we get into meteorological bonus features. Most of the state of Idaho covered in snow, as well as snow continuing to fall in western Pennsylvania. And the temperature has plummeted here following a very odd storm system on Christmas Eve. Here's what's going on in the cloud layer. And while it's light while we're making the video, it's still too dark to use the visible satellite at this time of day. And here's what's going on in the water vapor. And you can see those extreme bends in the jet stream there, as there's a south to north flow happening with the moisture pulling warm air into Maine, unseasonably warm air there, hitting Maine, and a massive pressure gradient right here, as well as a massive temperature and pressure gradient there. In other words, if you flew a plane across that area, if you're going east to west, you would seriously hit a wall of dense, massive air. Again, there's the cloud layer, and you can see that gradient there. High pressure versus low pressure, clouds versus clear. And we won't zoom in on any place, as again, we don't want the video to be too long, and we've got bonus features. A regular thing as I vanish here at the Smash News Network. Least busted name in news. Maybe I should trademark that. Do you think I should trademark it? Least busted name in news? And thanks again, everybody, leaving comments here. Stop asking me if I want to buy followers. In fact, you get a timeout for asking me if I want to buy followers. I don't want to buy followers. I'll never buy followers. It's not happening. That is a hacky thing to do. All right, so here's a colorized magnetogram. Close-up of sunspot 2795 and sunspot 2794. And it looks like 2794 is actually growing here. 2795 has remained very stable throughout its transit. 2795 looks like it's gotten bigger. And we see significant penumbra associated with that. So there's 2794, still quite large. The umbra is about the size of the Earth there. And there's 2795. Now, I'm not so sure that it's grown. It's actually degrading a bit here as we see less concentrated umbrae. So let's go to our Helio viewer movies and close things out. We've got close-ups, animated close-ups in magnetogram. Again, significant likelihood of solar flares, outside chance of an M-class flare, significant chance of a C-class flare yet. Although sunspot 2794 is approaching the Earth-facing zone, in which case the Earth-facing quiet effect will be in effect, and the likelihood of solar flares will drop, as it does when a sunspot directly faces the Earth. So there's a great view of that. Here's a close-up of just the intensity gram here. And indeed, sunspot 2795 is shrinking a bit. So it's lost a little bit of coherence there. And that drops the likelihood of solar flares. We've got two more. Here it is in 304 angstroms. Again, there is still some plasma filamentary material in between the sun and the Earth. Don't be surprised to see a coronal mass ejection in the Earth-facing zone, but especially in the opposite side of the sun. If it happens, we'll make a video about it. I didn't expect to be first, but people asked me to go to the front of the line. I didn't, but I was requested. Here's 335 angstroms. Another great view there in blue. And And that's another ionized state of iron, by the way. And here's 94 angstroms. And this is one of the two wavelengths specifically designed to study sunspots and solar flares. Anyway, that's about it. It's about time for me to close this thing out. Thanks again for tuning in, Twitch viewers, YouTube viewers, BitChute viewers, wherever you viewed it. Leave us a comment, share the content on your social media. Visit our website, support the channel, become a Patreon, etc. And since it'll never be now again, may that solar wind be at your back.